Hey guys, what's up, people? Welcome to the session. My name is Anoop, and this is Vedantu. I hope that all of you guys are doing good. So today, people, it's a new day, it's a new beginning. So it's a Monday. So let's begin with a new chapter for ICSE 10th. We'll be starting off with calorimetry, which is one of my that love hate wala chapter. This is that kind of chapter where you have lots of love, but then you also have a kind of like a little tiny bit of sprinkling of hate also. But yeah, nonetheless, it's an amazing chapter. So we will be studying about this one, that is calorimetry. Today we'll be understanding about the concept of heat and temperature. One of the two main basic things you must know regarding this chapter. So we will be understanding about that. What is the concept of heat? What is temperature? What is heat? We'll be talking about that as well. So welcome one and all. But before we get into the session, let me tell you how is the session divided into. So we have divided this chapter into five small sessions. The first one is concept of heat and temperature. Then you have heat capacity and specific heat capacity. Then it's calorimeter, change of phases and latent heat and specific latent heat as well. So that said, let's begin without wasting any more of your valuable time. Concept of heat as well as temperature. Let's begin. So, what is heat? Let me answer this question first. See, to truly understand heat, we have to go really deep, really deep down. Take an electron microscope, see how the atoms and molecules are behaving. Now, no matter what object you take, the atoms and molecules present inside that object, they're in constant motion. They're constantly, bickering with their neighbors. They're constantly fighting. They're constantly, like it's like a dashing car. Like if you go to an amusement park, they keep on hitting each other. This is constant. But no, again, it's not something that we can see, but it is happening at a atomic level. This is what is happening. The atoms and molecules are constantly in random motion. They are colliding with each other. It's constantly happening. Now, when you talk about this motion, because they are in motion, they obviously possess kinetic energy, because kinetic energy is what? The energy possessed by the body by the virtue of its state of motion. And also, if you talk about a solid or a liquid or a gaseous particle, they also have some amount of force between the particles as well, which keeps them together. It could be ionic bond, it could be covalent bond, whatever it is, right? So weak van der Waals forces. So you have so many different kinds of attractive forces between the molecules and atoms as well. Now, hear me out, people. Because of that, these molecules possess kinetic energy as well as potential energy. Because of the bond that they have potential energy, and because of the movement of the molecules, they also have kinetic energy. Now, when I say heat is given to an object, or when I say that the body possesses heat energy, what I'm trying to say is that these molecules, which are colliding and moving about each other, they start to move much more faster. The collisions will be more. They start to move even more, with greater force. Why? Because heat is a form of energy. It is a form of energy. So when you give that energy to these molecules, they start to move more randomly, colliding more and causing more chaos, as they're doing this. Now, if I have two bodies, one is cold and the other is hot, and I connect them with a bar in between, you can see that the heat would flow from the hotter body to the colder body. Never the other way around. Never from cold to hot, but always from hot to the cold body. And what you notice is that in the colder body, like if you were to again use an electron microscope and see what's happening to the molecules, you can actually see the molecules move more randomly. They get more energy, they get more excited, they keep on going about, like when you go to a museum, again when you go to a park and the kids are jumping about, so they'll be like that, they'll be that excited about it. Now that is what is heat. Heat is a form of energy which gives, or which makes the molecules move more randomly in a closed system. And heat, like I told you people, always flows from hot to cold objects, never the other way around. Never from cold to hot, but always from hot to cold. All right, now that is out of the picture. Let's define what we just saw here. So what is heat? The energy flow which flows from hot object to cold object is what is called as heat. When they are kept in contact, that is what is heat. So when you're keeping them in contact, the energy that flows from the hot object to cold object, again, how do you notice that? How do you see that? You can see that the cold object, again, if you were to look closely, you can actually see that the molecules and all start moving more randomly, which means that they're getting a lot of heat energy. So that's what is heat. Now, the quantity of heat, the measure of the quantity of heat is what is called as calorimetry. How much heat is getting transferred? What is the quantity? What is the amount of heat getting transferred? That is what is called as calorimetry. And the SI unit of heat is nothing but joules, just like that of energy. Here also it's joules itself. But the most common unit that we use, like for example, when you have food and stuff, we use calories and kilocalories. That is one of the most common kind of heat, unit of heat that we use. But then the unit of heat is actually joules. Let's say here it is joules. But then we also have the commonly used, like for example, you have a lot of others like that, like miles and kilometer. So it's just like that. So here you have calories as well. Right? So now that you've understood heat, people, I think you've understood that. I don't think there's any doubts right now, right? Now that you've understood this, let's understand what is calories. See, people, if I have to define what is 1 calorie is nothing but the amount of heat or the quantity of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. What does that mean? See guys, because of the heat energy that you give to an object, the temperature of the body will rise up, right? That's what happens. When you give heat energy, the temperature of the body rises up. So when you contact a hot object and a cold object, the cold object, you can slowly see the temperature of it starts to rise up. That's what is happening. So what is this calorie? Again, what is calorie? Again, it is a unit of heat, is one of the common units of heat. So what is calorie? How do you define it? 1 calorie. You're set to when 1 calorie of heat is said to be, or one calorie is said to be, you can say that the 1 calorie is the quantity of heat energy. Sorry about that. One calorie is the quantity of heat energy which is required to raise the temperature of 1 gram of water through 1 degree Celsius. Now the fact is this, people, it's not going to be always the same. For example, you require more amount of heat energy when you're raising the temperature of, let's say, your water from, let's say, 1 degree Celsius to 2 degrees Celsius. You need a lot more heat energy. Maybe when you're, maybe at 93 to 94, you want to raise the temperature from 93 degrees Celsius to 94 degrees Celsius. Over there, the amount of heat energy required is less. The amount of heat energy required to raise the temperature from 1 degree Celsius to 2 degrees Celsius of a cup of water, of 1 gram of water again, that would be far more greater in comparison to the amount of heat energy that you require to raise up the temperature from 93 degrees Celsius to 94 degrees Celsius. But according to the calculations, according to the scientists who have calculated, who have done so much experiments on this, they have found out that exactly 1 calorie is used up. The amount of energy is exactly 1 calorie is used up when the temperature is between 14.5 degrees Celsius to 15.5 degrees Celsius. Exactly this temperature, exactly from 14.5 to 15.5 degrees Celsius, the amount of energy required over here in this duration is exactly 1 calories. Otherwise, it's different. Sometimes it's more, sometimes it's less. But then, because according to the definition, what does it say? 1 calorie is the amount of heat energy required to raise the temperature of 1 degree of 1 gram of water by 1 degree Celsius. So here it's very clear that between 14.5 to 15.5, the heat energy required is exactly 1 calorie. In terms of joule, that means that if you have to translate it in terms of joules, that's 4.186 joules, or you can say it as 4.2 joules. And the fact is this, people, from 14.5 to 15.5, the amount of heat energy that you require is actually 4.82 to 4.182 to 4.186. So it actually lies between this region itself. That is why, people, you can see that the temperature between that is to raise the temperature from 14.5 to 15.5, it's exactly 1 calories. I know I've been explaining this a lot, but yes, you have to understand that this is how it is. Now you have to understand this, people, that for 1 calorie of heat energy when you give to water, it will raise the temperature by 1 degree Celsius. But for other objects, like for example, aluminium or lead or iron, it is completely different. This 1 calorie in let's say aluminium can raise the temperature by 4.4 degrees Celsius. Look at the difference. That same 1 calorie can give you a raise of 1 degree Celsius in water, but in aluminium it gives you a raise of 4.4 degrees Celsius. So there's a massive difference because it depends on the nature of the object as well, right? So that is one more thing that you have to understand, because every object and at different temperature they have so much amount of heat energy that they require in order to raise the temperature. That is what I'm trying to convey to you. Right. Anyways, now let's talk about kilocalorie. 1 kilocalorie is nothing but the amount of heat energy, the same sentence, that is required to raise 1 kg, the water 1 kg from 14.5 degrees Celsius to 15.5 degrees Celsius. The amount of heat energy, the quantity of heat energy that is required to raise the temperature of 1 kg, not 1 gram, but 1 kg of water from 14.5 degrees Celsius to 15.5 degrees Celsius. In other words, 1 degree Celsius. That is what they're trying to say. So increasing that temperature, because again, 1 kilocalorie is 1000 calories, which is equal to 4200 joules as well. Right? I hope you understood, people. Now that you understood that, let's talk about temperature. Right? Every one of us has had this one problem where we try to fake that we have a cold and stay at home. Yeah, I know you guys. Before the COVID-19, now all of you guys want to go back to school. But there was a point of time where you used to fake your, fake that you have a cold because you're too lazy to go to school and you used to stay at home. Yeah, I know. I've been there. What is temperature though? In simple words, temperature is the degree of hotness or coldness of an object. The degree of hotness or coldness of an object. It tells you how hot or how cold an object is. Right? Now the heat, or when you talk about heat energy, like I told you, it always flows from higher heat energy, or from a hot object to a cold object. So temperature will help you determine what is the flow of heat energy. For example, let's say an object has a temperature of 100 degrees Celsius. There's another object with 50 degrees Celsius. Where do you think how is the heat going to flow? From 100 to 50 is what's going to happen. Not from 50 to 100. It will flow from 100 degrees Celsius to 50 degrees Celsius itself. Why? Because heat always flows from from high energy to low energy. In other words, from a hot object to a cold object. So this temperature tells you how hot an object is or how cold an object is. That is what it tells you. And generally we measure it in degrees Celsius. We also have Kelvin. We have degree Fahrenheit. So many different units are there to measure temperature. But ultimately this is what it tells you. So if you have to define what is temperature, temperature determines the flow of heat when two bodies of different temperature are placed in contact. So it tells you, again, understanding the temperature will help you to determine how the heat flow is going to happen. The SI unit of temperature is Kelvin, but the common unit, again, in India especially, we use it in terms of degree Celsius and degree Fahrenheit as well, right? Now, you have to understand a little bit more about this Kelvin. This Kelvin, who is this Kelvin? Let's understand that. Kelvin is the SI unit of temperature. We just told that. 1 degree Celsius in terms of Kelvin is 1 degree Celsius in terms of Kelvin is 1 degree Celsius is equal to 273.15 plus 1. In terms of Kelvin, this 1 degree Celsius is 274.15 Kelvin. So in other words, 0 degree Celsius in terms of Kelvin is 273.15 Kelvin. Now this is how you're supposed to convert. If you're ever asked what is the relationship between the two, it's simple, guys. In terms of Kelvin, if you have to talk about the temperature in terms of Kelvin, it is 273.15 plus whatever the temperature is. With 273.15 plus 5. So whatever is the temperature, you have to add 273.15 to it to find out the value in terms of Kelvin. That is what I'm trying to tell you. So 273 Kelvin, just to round it off. So it's 273 Kelvin. That is what it is. So 1 degree Celsius is 273 plus 1. That means 274 Kelvin is what is 1 degree Celsius. So this is the relationship between Kelvin and your degree Celsius. Now, in terms of Celsius, think about it. 0 degree Celsius, I told you, is what? 273.15 Kelvin. If you talk about 0 Kelvin is minus 273.15 degree Celsius. This is called as absolute zero temperature. This is called as absolute zero temperature, where the molecules that are there, these molecules that are there, those would completely stop moving. They completely stop moving because all the heat energy is taken away from it. But then it's a it's almost an impossible case because there's always some sort of loss happening. But in an ideal situation, people, if you reach a temperature of minus 273 degrees Celsius, that means that you've reached absolute zero temperature, which means that in terms of Kelvin, that's zero Kelvin, where the motion of the molecules completely would cease. Now this is why, okay, this is one of the reasons why it is used in, this is the temperature that you maintain in cryogenics and all that, where things like, people like in movies and all, probably seen all these X-Men movies and all, people are staying in cryo, they stay young for 20-30 years just like that, and then they suddenly come out with blades and everything. So that's what it is. So that is the cryogenic temperature. Basically, you're trying to attain that particular temperature, that is minus 273 degrees Celsius. Once you attain that, that is where you call it as absolute zero temperature. So at that time, the cells would stop to function, the atoms and molecules would completely stop motion. So it will stay like that for a very, very, very long time. Alright guys, so all this while we've been talking about heat and temperature, those were the topics, those are the major topics that I had to talk about. But let's talk about what are the factors that affects the quantity of heat absorbed by an object, which later on is used to increase the temperature of the body. So what are the factors that it depends on? The first factor it depends on is the mass. Greater the mass, more is the heat energy. Lesser the mass, lesser is the heat energy. For example, if you just take, okay, I'll just give you an example. Let's say that you have a beaker and you put a little bit of water and you start heating it up, and you have a beaker which contains 1 liter of water and you try to heat it up. You see that this will heat up really fast. The bubbles will start to come out, like it'll start boiling in just a couple of minutes. But here, on the other hand, it'll take much more longer time. Why? Because the mass is more. More the mass, more is the heat energy. Second thing that it depends on is the temperature of the body itself. That is the increase in temperature. Because like I told you people, I gave you the example of water. In some cases, like when it's from, let's say from 1 to 2 degrees Celsius, you want to increase the temperature. You require more amount of heat energy. And if you want to increase the temperature from 94 to 95, let's say, over there you might need less heat energy. So the increase in temperature also, like basically at what temperature the body is, that also matters. So an object which is cold, like like for example, let's say that an object is at 20 degrees Celsius or something at room temperature, or 24-25 degrees Celsius, and in those cases you don't require less heat energy is what you require it basically to heat up. That is all you need. Less amount of heat energy is required for it to raise the temperature. But at higher temperature, they might require more amount of heat energy to increase the temperature. So that is one more thing. It depends on the amount of temperature the body already has, is also something that matters. The third and one of the most important factor is the material of the body. Like I told you guys, so this is actually called as we'll talk about it later, but it's called a specific heat capacity. So that means that how much amount of heat energy can the body retain. Like if you can retain more amount of heat energy, then that will stay, that will be hotter, that will be, stay hotter for a longer time, and more importantly, it will be able to absorb more amount of heat energy as well. If an object is not able to hold on to that heat energy, that means that it will not be able to absorb as much amount of heat energy as the body that can hold on to the heat energy as well. So that the material of the body is also something that matters. But don't worry guys, we'll be talking about that in specific as we go to the later session, so don't worry about it. And one last thing I would like to talk about is something that all of you guys are thinking about right now. So what is the difference between heat and temperature, right? Let's understand that. What is the temperature? What is the difference between heat and temperature? Let's talk about it. Heat is a form of energy that flows from hot object to cold object when it's in contact. Temperature helps you to determine what is the direction of heat energy. What is the direction of flow of heat? It tells you whether it's going in left or right. That is from like two bodies are in contact, whichever is the hotter one, it tells you which direction the object is going, like the heat energy is flowing. Is it from left to right or right to left? Whichever is the hotter one, so it tells you to determine that. Heat is the amount of heat energy contained depends on the mass, the temperature, as well as the substance, that is the material as well, the property of the material as well. when you talk about temperature, temperature of the body depends on the kinetic energy of the molecules. Like I told you, more the movement of the particles, more the movement of the molecules, more amount of heat energy it will contain. That means the temperature would also be more. Thirdly, the two bodies having same quantity of heat may differ in terms of temperature. That is possible. That the amount of heat energy they might contain is the same, but then the temperature might be different. All right. So this is one thing that is possible. Like I give you an example. No, one calorie in terms of, if you talk about water, that is 1 calorie can raise the temperature of water by 1 degree Celsius. But in aluminium, it can raise the temperature by 4.4 degrees Celsius. So there's a huge difference. The amount of heat energy you're given to them is the same. 1 calorie is what you're giving. But then the raise in temperature is different. So that is also possible. But temperature, again, temperature also is the same thing. So temperature depends on the amount of heat energy. So two bodies having the same temperature could have different heat energy as well. It's vice versa. It's not like one way, it's vice versa as well. And finally, guys, the SI unit of temperature, heat is nothing but joules. SI unit of temperature is nothing but Kelvin, right? And with that, people, I hope you guys are enjoying the session so far. Hit that like button, subscribe to the channel. We will be getting into the questions right now. But before we get to that, people, if you guys want to have more such amazing session and have a lot of fun and gain 100% knowledge and gain 100% mark, all you got to do is click on the link that is given in the description as well as in the pinned comment section. Let me tell you what are the advantages of joining the platform of Vedantu, where you have the opportunity to learn with the best of the best teachers that is there out there in India to gain knowledge and to gain marks as well. So you have the opportunity to attend unlimited live session. There is no limit to it that you have to attend only 5 sessions or 10 sessions. No, you want to attend 20 sessions, 30 sessions, it's totally up to you, people. It's you who's going to decide your future, not us. Unlimited live sessions with a lot of fun and also the best level of quizzes, the highest level of quizzes in every single session. With the quizzes, you have the opportunity to compete with the rest of the world because you have an opportunity to see how good you are at a subject. Like some of you guys might think that's around like I'm great in math, I'm awesome in social science. This is the chance for you to compete and see how good you believe you are. That is something that helps you to understand from these sessions. With that, because live sessions are going on 24/7, it's not possible, humanly possible, for you to attend all the sessions. We're not robots. No, we can't sit in front of the computer for the whole day. No matter what it is, even if you miss out a session, you can still take part in the quizzes with the help of the live interactive replays. So you can actually take the quizzes even after the session is done and check out the leaderboard as well. So you never miss out on what many of you guys join the session for. The quizzes, you can actually attend the quizzes even if you don't attend the sessions. And people, you can download all the premium content and handwritten note of every single session. I know there's a lot of ands in this because there's a lot more that we're giving. So yeah, people, you have the opportunity to download all the content and the handwritten note of every single session. So you never, ever miss out on anything that is important. Added to this, you have, I would say, one of the best feature is that you will not just have one master teacher to help you understand the topic, but together with the master teacher, you will also have the class teacher to help you clear every single doubt of yours. So you will not have one teacher teaching you. In fact, you'll have 2 teachers to help you guys out to make sure that you guys are understanding every single topic taught inside of the class. Right? And just to give you a good practice of how the exams are going to be, you have unlimited number of tests and assignments, so many tests and assignments that you guys would find really helpful in order to practice, in order to make yourself better every single day before the start of your final exams as well. And guys, yeah, we're not done yet. 5,000 plus micro courses and crash courses, all for free. So much more, and a lot more for a lot less. That is what you're getting at Vedantu over here. Value for money is what you're getting over here. So people, if you go to the link, they'll ask you for a coupon code. My coupon code is AMEPRO. This is my coupon code to avail the discounts. So if you go for the 1 month program, which is basically 30 days, the base price of that is 2,699 rupees. And on top of that, if you use the coupon code AMEPRO, you get a discount of 500 rupees and the price drops down to 2,159 rupees. And yes, people, because your exams are going to start later on this year, we have extended our sessions until June of 21st, which means roughly about 5 months from now, which means for all of that 5 months. So imagine this, 2,000 per month is like 2000. Okay, we'll just take it as 2000 for now. 2000 is what you're paying for 1 month. For 5 months, that means it's 10,000 rupees. But if you use the coupon code AME Pro, you get a discount on that. And what you're essentially paying is just 7,200 rupees. That means you're getting a discount of about 3,000 rupees. More than 3,000 because it's 2,159. It's more than 3,000 rupees. So that is the discount that you're getting it. And more importantly, people, why do I say value for money? Because in that 1 month duration, you would have roughly attended about 200 sessions. That means that you are paying about 11 rupees per session. And if you go for the 5 month program, which I would suggest you guys to go to, that would mean that you've attended about 1,000 sessions, which means that you're paying about 7.2 rupees per session, which is less than 7.2 rupees is less than a packet of, forget about Lays. Lays is still 20 rupees. Packet of Parleji biscuit, like the 10 rupees wala biscuit. So that's how it is, people. It's for your own education. It's for your own good. The link is given in the description as well as in the pinned comment section. Once again, guys, we will make sure that you guys are getting the best of the best technology out there to make sure that you guys are doing the best. We'll do our best to make sure that you guys are getting all the support that you need, but it's a two-way street. So when we do something like that, you should also promise us that you'll work with us, and that is what is going to help us achieve that 90%, 95%, and 100%. Right? I'm not going to make you any false promises, but that is the fact. Right? So with that said, let's move on to the questions. Let's solve some questions and see how many of you guys have understood everything for today. Here's the first question. The principle of measurement of heat is based on the what? The law of conservation of energy, law of conservation of momentum, universal law of gravitation, or universal law of cooling. Newton's law of cooling. Interesting. All right. In 5, 4, 3, 2, 1. The answer, people, is definitely law of conservation of energy, because energy can neither be created nor destroyed. It can only be transferred from one object to another. Now, in this case, the energy is transferred from one hot object to a cold object. So it's law of conservation of energy is what you have. Second question. Here's another one. The quantity of heat energy required to raise the temperature of a body depends on what? The mass of the body, the nature of material of the body, the rise in the temperature of the body, or all of the above. Go ahead, people. The quantity of heat energy required to raise the temperature of a body depends on what? Mass of the body, nature of the material of the body, or raise in the substance, or temperature of the substance or the body, or all of the above. Once again, 5, 4, 3, 2, 1. All of the above. Definitely all of the above. Mass of the body, yes. Q depends on, Q is nothing but the heat energy. It depends on the mass, the nature of the material, and the temperature of the body as well. Moving on to the next question. The third question. When water solidifies to ice, heat is absorbed, heat is released, temperature increases, temperature decreases. When water turns into ice, like when you put it in the freezer, water turns into ice. So what's happening over there? Is heat absorbed? Is heat released? Is it the temperature increases or the temperature decreases? 5, 4, 3, 2, and 1. Heat is released because it's an exothermic reaction. You're releasing the heat energy so that the temperature drops down and it solidifies, right? So that is the answer. It's basically a state of change of matter. Here's another one. The kinetic energy due to the random motion of molecules of a substance is known as what? The kinetic energy due to the random motion of the molecules of substance is known as temperature, heat energy, chemical energy, or both temperature and heat energy. The kinetic energy due to the random motion of the molecules is 5, 4, 3, 2, 1. Heat energy, people. The kinetic energy due to the motion of the particles is heat energy. And temperature is, again, it tells you what direction the heat energy is flowing. So that is the answer, people. This is your homework for today. The measurement of quantity of heat is called as what? Let me know what is the answer in the comment section. Whoever puts down the answer fastest will also be getting their name published in the next session. Before the start of the next session, you will have their pictures on the screen as well. So once again, thanks a lot for joining. And by the way, people, happy Republic Day in advance. Jai Hind. Have a great evening ahead. See you all in the next one. Take care. Do not forget to subscribe to the channel. That's important, or it's bad luck for the whole of 2021. Make sure that you don't have that. Bye bye for now, people. Take care of yourselves. Stay safe and great day. Bye.